The last thing we want to look at with surds is this specific idea of rationalising the denominator. I guess the simplest type is one like that, where it's simply a single surd on the bottom of the fraction. And so to rationalise, make it a rational number, we multiply it by itself, because then we can use that rule that the square cancels with the square root, and we end up with a rational number. And so of course we get 4 root 2 on 2, which is 2 root 2, which is brilliant when there's just one surd on the bottom. By the way, I put this one here just to highlight. You only need to multiply by the surd. I mean, it would work if I multiplied by 2 root 5 on 2 root 5, but it means that there'll be more cancelling to do later on. So, make life easy for yourself. Just multiply by the surd. So the root 5, and we get 3 root 5 on 10. Why on earth do we insist on having a rational number in the denominator? For what reason would there be? And there really is only one. It's all to do with comparison. How do you compare two things? So if I said to you, I've got 1 over root 3 and I've got root 3 over 2, which one's bigger? So you got to think about that. You got to think about that, right? Whereas if the surd is on the top, a lot easier to compare. 3 on root 2 minus 1, so we get 2 terms in the bottom. That's when we multiply by the conjugate, because we'll get difference of 2 squares. Again, we create a rational number. In this case, 2 minus 1, which is 1, and we have 3 root 2 plus 3. And just one more. So 2 minus root 3, we'd multiply. Amazing how often you see this question, or one very similar to it, where the numerator is the conjugate of the denominator, so you end up with a perfect square on top and difference of 2 squares on the bottom. So we get 4 minus 3, and there's 7 plus 4 root 3. That's pretty much it. That's all I really want to say today. So, there we go.